Alright, so this is how to turn standard form into vertex form. This is standard form right here. It's a quadratic form that we usually learn first. You know, A is a number and B is a number and C is a number. It's a quadratic because it has a squared term. And these are all parabolas. You know, so these are like smiley faces and this is a frowny face. Notice that this one crosses twice, so it has two values that work for x. This one crosses once, so it's a repeated value. This one doesn't cross at all, which means the solutions are not real values. So there's no x value that would fit in for this because it doesn't cross the x-axis. So that's just kind of a little review. You know, we're talking about parabolas, and there's two forms of parabolas. This is standard form, and this is vertex form. And basically they give you different information, and you can convert from this to this and then back again. And it's handy to know both just so you're versatile, so you have both tools in your toolbox. So let's look at this problem here. Negative 2x squared take away 8x take away 1. Alright, I want to convert this from standard form, which it is in now. This is your A and your B and your C, into vertex form, which is this. You know, the first thing you want to think about is you can't have a coefficient here in order to complete the square. And when I say complete the square, it means making a perfect square trinomial so it turns into this business here with a x minus h squared. If I'll just write down, you know, the perfect square trinomials are nice to know by heart. It's a squared plus 2ab plus b squared, and that converts to or equals a plus b parentheses squared, so the square of a sum. So, you know, these are different forms of each other, and we want to make this happen so we can get to this. That's what we're trying to do here, is we're actually not going to use this one. So you see how it's moved outside, and we're just working with the inside. So we're going to work for these first two terms here. And so I put them in parentheses here, and then since you can't have you know, a coefficient on the x squared term, I'm just going to divide the negative 2 out. You know, staying on the same side, divide negative 2 here, you just get x squared, and negative 2 comes out. Divide negative 2 here, and the negatives cancel, you get positive 4x when the negative 2 comes out. You know, and if you distributed these back through, you should be able to, you know, get back to the negative 2x squared minus 8x. So negative 2x squared, and then negative 2 times 4 is 8x. So I think we're good there. I left a space here with a box because we need to fill in this box with something that works in this pattern so that we can change it to this, because that's what the form requires. So you know, I've done these a lot, so I've completed the square in order to solve problems before, and that's what we're doing here, is completing the square. So just ignore this 1 because we moved it outside. Ignore the negative 2, which we factored out. You know, what would complete this pattern here of 2 times a times b? Now, 4x is the 2 times a times b, so you know 2 times something makes the 4. And the a is just kind of equivalent to the x here. In fact, I probably should have written this with x's instead, you know, of the b or the a's. Okay, so you know, the 2 times the b is the 4, and so 2 times what equals 4, or in other words, 4 divided by 2 is what? So you get a 2 if you divide the 4 in half, and so you take this middle number, divide it in half, and you get a 2, and remember there's a b here, and so 2 times 2 is 4, and so then that number is squared here. So 2 squared goes here. Okay, so now this fits the pattern over here. I should have written it right here. Anyway, so this fits the pattern now, but we just added something to this whole side, and now the equation is unbalanced. And whenever you add something to a side, you have to do it to the other side too, or subtract it off of the same side in order to keep things balanced. So what did we really add? Well, this is 2 squared, which is 4. Did we add a 4? Not really, because this is within parentheses, and the parentheses are governed by this -2. So -2 times 4 is -8. So what we really did is add a -8 to the right side of this equation. And if I add a -8, then in order to keep the equation balanced, I'm just going to put a +8 out here. You know, it's on the same side, so, you know, this +8 balances out the -8 that I added in. And so it looks like I'm adding a 4 here, but what I'm really adding is a -2 times 4, which is -8. So -8 plus 8 is 0, so this balances out this that I added. Alright, and so now this right here converts to this, just like we saw over here. If I wrote this in x terms, this converts to this. And so once I have completed the square, I can change it to this, which is x plus 2 squared. And then this and the 8 combine to make a 7. So -1 plus 8 is 7. So I have a 7 on the outside now, and that ends up being my k here in the equation. But notice there's a negative in the equation here. I can't have a positive. And the only way that happens is if there's a double negative. That's why there's a positive here. So I can convert the positive to a minus -2. And so here is my vertex form. So the vertex of my parabola should be the h and the k. Okay, so hk, that's like the vertex, you know, the bottom of the parabola, or the top if it's a frowny face. In this case, it is a frowny face because the coefficient's negative. But -2, 7 is my vertex according to this form. And we can check that using the standard form. If you remember, the axis of symmetry for standard form is -b over 2a. It's part of the quadratic formula too, but you know, kind of like the first half. If we do -b over 2a, it's like -8, which is just +8, because b is -8. And then 2 times a, which is -2, is -4. So we get, you simplify this and you get a -2. And that's your x value. That's your axis of symmetry. And then to find out the y value here, you just plug the x value into the function here that we started out with, see? And you just plug -2 in there and there. And simplify, zoom, 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 and you get y equals 7. And so that's your vertex. And that matches this. hk is -2, 7. So that's my vertex. You know, you can graph this. It's a frowny face, and the vertex is -2, 7. You know, you could plot some extra points, or you know, see if this factors in order to find out where it crosses the x-axis. It does cross the x-axis twice because the vertex is above the x-axis, and I know this goes down. So, if I plot -2, 7, okay, that's where the vertex is, and I know this parabola folds down. So, you know, it's going to be, you know, something like this. And so it does cross the x-axis somewhere. And so if you want to graph, you would have to, you know, find out where it crosses. But for now, that basically answers the question how to put in vertex form. You know, the axis of symmetry is covered here. This right here is -2, and x equals -2. So the axis of symmetry is here. And you know, you could state the x-intercepts, you know, where it crosses. If you want to state the y-intercept, you'd put in a 0 into your function. And if I put in a 0 here and here, it would give me that it crosses the y at -1, so I know it crosses here. Okay, so you know, there's the graph. Domain is left and right. It goes on forever and ever. It goes down forever, but does not go up forever. It stops here at what was this, 7. So you know, the range is 7 or below, and the domain is all real numbers, both left and right. So hope that helps out. And may the force be with you.